Okay, this question was about 28 in 6.3. I kind of just included the whole diagram right here. And in 28, we want to take, okay, region A, so that's important here. I'm not worried about B, but just region A, and revolve that around the line y equals -2. So I'm going to draw this graph a little bit bigger than I have it right now. Here is my x-axis. We're going out by -2 here. So, okay, this line right here then, guys, becomes our axis of revolution. Okay, that's the line y equals -2, and our quantity is rotating this way. Once again, boy, I feel like every problem I'm doing is working out the same way. It's a horizontal axis of revolution, and that means that this is a dx problem. So we're going to take region A, which I tell you what, I'm going to outline here in blue. Region A is this guy. All right, there it is. And we're going to spin that around this line of y equals -2. So I'm going to draw my 180-degree reflection. So from about here to here, it's going to go straight out like that, and then I'm going to kind of curve this thing back and looking like that. So there's the 180-degree reflection of A, and if you wanted to draw what this thing would look like here, guys, all right, you'd get this, but also then we've got this gap right here in the middle. I think you can see that's going to create a hole there as well. So once again, and I hope you guys are getting the hang of this right here, because we have this big gap right here, actually, excuse me, that whole gap right there between region A and the axis of revolution, that means when we spin this thing, there's definitely going to be a hole in the middle. This is once again a washer problem. So let's get working on this, guys. Formula for area of a washer is going to be pi times big R squared minus little r squared. Okay, then let's get working at figuring out what those radii are. So we always start drawing these from the axis of revolution. I'm going to say that as many times as I can. Then from there, you go to the original function, the original region, which in this case means up, and we go through the first curve until we get to the second curve. So that segment that I just drew there in dark green is R. And how long is R? Remember, guys, I want to get everything expressed here in terms of X. Well, R we measure as top minus bottom. And what stops R on top? Well, right there, it's the horizontal line, y equals 6. Minus, what stops R on bottom? Another horizontal line, and that would be the line y equals -2. So 6 minus -2 becomes 6 plus 2, which is 8. And this is a little bit unusual, guys. That expression right there has no variable in it. We're saying that regardless of your x value, R, take a look at where I slide this, guys, R is going to remain constant at 8 units long. And I'm hoping you guys can see that. Yeah, that actually looks right in this figure. So it's unusual, but I believe that's correct. All right, let's go purple now. All right, little r. Again, we start at the axis of revolution, and we go to the original region, but we stop when we hit the first curve, and that is little r. So how long is r? What stops it on the top? That would be the function y equals x squared plus 2. And then minus the bottom border of little r, which is y equals -2. So minus -2 again becomes a plus 2, and that simplifies to an x squared plus 4 for the length of little r. And I think you guys can see this. The bigger x gets, the larger the value of little r is. As I move this thing to the right, as x gets bigger, r is going to need to get longer. If I were to move it to the left and x would get smaller, r would need to get shorter. So it makes sense to me that that one is a variable quantity. Okay, so here's your area function. We now know both big R and little r in terms of x, so let's put it all together, guys. A of x is going to equal pi times, and here we go, big R squared is just going to be 8 squared. I'm going to go ahead and save some time and write that as a 64. So that's big R squared minus little r, which is x squared plus 4. That quantity gets squared as well. And I could expand that out. I don't think I'm going to on this one here, guys. I think I'm going to leave that as is. and let my calculator do the hard work for me right here. Okay, so now that we know what a of x is, now let's go ahead here and start doing our volume integral. Volume is a definite integral, we said a while ago, with respect to x of this a of x function. So I'm going to pull the pi all the way out in front, and I'm going to go with a 64 minus x squared plus 4 quantity squared, all taken with respect to x. Limits of integration here, everybody, too much purple going on, would be the lowest and highest values of x in this region. Well, region A begins right here when x is 0, and it ends right over here where they told me x was 2. So I feel like that's an integral I probably could do by hand, but again, you guys will be able to use your calculators here the whole time. But as I'm about to do it, don't forget the pi out in front, which I have to remind myself because I do a lot. Pi, I think you guys probably do too, times a definite integral now. We said from 0 up to 2. And our integrand, we had the 8 squared, so that was a 64, minus, and then in parentheses here, do I remember what it was? X squared plus 4, I think. X squared plus 4. We want to close that parenthesis and then do quantity squared there as well. And we want to integrate all of that with respect to x, and I'm pretty sure 64 minus x squared plus, yeah, that looks good. Okay, go me. All right, plug all that in. And I got this answer here of 214 point blah, blah, blah. I kind of wonder, let me think here, guys, just humor me for a second. If I divided that by, oh no, that's ugly too. All right, I'm going to go ahead and just write down that decimal answer. I'm curious here for this problem, what the book had for the answer. I'll come back to that one in just a second. So we had 214.466 for this answer here. 214.466 volume problem, so we'll go cubic units. Okay, so 6.3, number 28. I'm looking at the solutions manual right now, and wait for it, there we go. They gave me 1,024 pi over 15. So let me just check that real quick. 1,024 pi divided by 15. Yep, there's the answer I had there before as well. I feel like your calculators probably would have given that to you. I don't know why mine gave it to me as a decimal. Maybe it's a setting I have right there. Anyway, regardless, you'd get full credit for either the exact answer, the way I have it typed in right here, or the rounded or truncated answer, as long as you've got it correct to 3 decimal places. So, any way you slice it, that's the right answer then for problem number 28.